This video recording involves the exploratory data analysis of the Titanic dataset. Initially, the general prerequisite packages are installed. The installation of the scikit-learn passage also takes place. After this, the import of the general libraries like the pandas library, the numpy library, matplotlib library, the scikit-learn library and the cboard library, which will be used in the further stages for visualization as well as data analysis, are being used. Matplotlib inline function is used to present all the graphs in the same page rather than the opening of the graphs on a different tab or on a different browser. After this, the import and the upload of the dataset takes place. The df.head function is used for obtaining a general overview of the dataset which has been provided for analysis. It helps us to get a basic understanding of the columns which are present in the dataset and the different informations which are being conveyed by means of those columns. The dataset which has been imported is then converted into the data frame by means of the data frame function. The conversion into the data frame is taking place in order to make our task easier, and the data frame handling is also much easier for the pandas as well as the numpy library. The conversion of the dataset into the array takes place by making use of the data frame function. After this, the dropping of the irrelevant columns is taking place by means of the drop functions. Some types of columns like the home destination, body, boat, etc. are not required for the further analysis and they might interfere with the usual working of the EDA. So therefore, it is always considered fit to drop these columns. So therefore, these columns are dropped. And then after dropping these columns, the dataset top 10 rows are again visualized once again in order to ensure the successful compilation of the function. After this, pre-processing as well as label encoding takes place. The major purpose of performing label encoding is because it is always easier to work with numerical values rather than our working with string values. Due to this reason, the gender, cabin, etc., certain values which have been processed in the form of strings in the original dataset are now converted into numerical form. The inbuilt function of Python allots them a definite value. Like in case of gender, the male values are allotted a value of 0 and the female gender is allotted a value of 1. After this, the embarked attribute is also label encoded into numerical values. For checking the successful compilation, the top 20 rows are visualized. After this, we obtain a general overview of the columns which are present. This is done simply in order to ensure that all the columns which are present are the relevant columns and no irrelevant column is still present in the dataset. In case if it is found so, then in that case that column has to be eliminated as it might interfere with the normal working of the EDA. After this, the name column is found to be irrelevant and not required for the further analysis, so therefore it is dropped and the top 10 rows are visualized. After this, the implementation of the fill_NA function takes place. The fill_NA function is used to fill in the missing values in the dataset. In this case, the fill_NA function will fill the missing values with the value of 0. However, the fill_NA function can also be used to fill in the missing values by the mean values of that column or by the values of NA and etc. It depends upon the user. After this, we count the number of values which are present in the attribute cabin and the number of distinct values which are present. After this, the label encoding of the cabin value also takes place. From here, a successive series of different types of scatter plots, histograms, density plots, box plots, violin plots, etc. will take place, which means that the detailed exploratory data analysis of the dataset will begin from this point onwards. This will help the user as well as the customers to get a clear picture of what is there in the data set, the different interlinks between the various attributes which are present in the data set, and how should we proceed with the various attributes and the further machine learning models. This is the interrelation which is there between the survived values as well as the age. That is, according to the different age groups, how many people have survived. The interrelation between cabin and the survival rate, because the number of people who are present in the different cabins would have different survival rates. The interrelation between the embarked values as well as the survival rates, and the interrelation between the sex of the person as well as the survival rates. After this, the SNS.pairplot function is implemented. The SNS.pairplot function provides a complete 100% cross-relational analysis between all the attributes which are present in the dataset. It provides detailed graphs of all the attributes with each other as well as the self-attributes interlink relations are provided by this method. It may turn out to be useful in case of those datasets which have a few number of columns. However, in case of those datasets which have a very large number of columns, this method might not turn out to be so useful because the graphs which are obtained are very small as far as their scale is concerned, and it becomes difficult to visualize them. And the numerous graphs which are obtained on the same page also makes it confusing for the reader to visualize the relevant information. The histogram shows us the frequency distribution of the survival rate, the frequency distribution of the age, the different numbers of the people who are present from various age groups. The tail function helps us to visualize the last X number of rows of the dataset. And after this, the bar plot is obtained for the P class as well as the survival rate, which helps us to count the number of people who have survived from a particular class. Number of people who have survived from a particular class in this case. And then the fare is present, quantile values are calculated. In order to calculate and build the machine learning model, it is very important to keep in mind certain attributes. In order to build the machine learning model, we need to have an account of the statistical values of the dataset, which involves the interquartile ranges, mean, median, frequency distributions, etc. So for that purpose, the interquartile ranges are calculated of the fare attribute, median is calculated, mean is calculated, maximum and minimum values are calculated, and a histogram is plotted for better understanding. The interquartile range also helps us to visualize the broad width or the bandwidth in which the data is spread. Whisker values are also calculated. Whisker values also help us to get an account of the outlier values. And after this, a box plot is calculated. A box plot gives us a complete visualization of the mean, median as well as the outlier values and the maximum and the minimum values of a particular attribute. This analysis of the spread of values in a particular attribute helps us to understand the attribute better and also helps us in the selection of the machine learning model. The periodic visualization of the top X number of rows of the dataset or the bottom X number of rows of the dataset is taking place in order to ensure that whatever steps we are taking are being successfully implemented and the compilation is being carried out effectively. The mean value of the fare is calculated, and after this the normalization function is implemented. The use of the normalization function will be carried out at later stages. And the scatter plot between the sex distribution and the age distribution gives us a clear picture of the type of people who are present at that point of time in the ship. Joint plot is calculated or plotted between three major attributes, which involves the fare, survived, and the hexagonal plots are being used in this case. Distant plot is used Distant plot is used, which gives us a density distribution of the fair values in this case. From here, the actual training of the machine learning model begins. First of all, the dataset needs to be shuffled in order to ensure an unbiased output. The dataset needs to be shuffled in order to ensure an unbiased output. And after that, the dataset needs to be split into the training data as well as the testing data, out of which the survived attribute is placed on the y-axis and all other attributes are placed on the x-axis. This is because the survival rate of a person depends on several factors, like the age of the person, the cabin in which the person was staying, the gender of the person, etc., which implies that the survived attribute is the dependent attribute and hence it is being taken as the y variable, and all other attributes are the independent attributes, hence they are being taken as the x variables on which the survival rate depends. Usually the split between the training dataset and the testing dataset is 70% and 30% of the entire dataset. However, in certain types of software packages as well as machine learning models, the split between the training model and the testing model might also be 80% as well as 20%. It won't make much of a difference at this point. And then we find out the sum of the null values, which comes out to be 0, which ensures the fact that there are no null values present in the data set. And then the data types of the different columns are calculated. The number of values in the fair data type are calculated, and these values are calculated in the normalized form. And now we will be implementing the regression machine learning models. The ticket attribute is dropped because it is of no further use for the further build-up of the machine learning model. After this, the training dataset and the testing dataset are trained according to the selected machine learning model. Random state is taken as 56. The usual random state, which is taken in most of the ML models, is also 42 in certain cases. However, the random state value can be any integer, which should be greater than 1. It basically acts as a seed generator to the actual machine learning model. And then train X shape, train X, test X shape, train Y shape and test Y shape are also just output. They are also visualized in the output function in order to get a clear picture of the number of rows and the number of columns which are present in the training data set and the testing data set. Then the actual logistic regression model is implemented and the predicted values are visualized in the output function. These values which are obtained here are the predicted values from the machine learning model. The accuracy and the fit score of the machine learning model comes out to be approximately 80%. This score can be better improved by better shuffling and cleaning of the data. Decision tree classifier is also implemented. Decision tree classifier is also implemented in order to check whether it will be a better model or not. However, the score which is obtained from the decision tree classifier is only 9%, which is a very less score, which shows that it is not a fit model for this dataset. The k-neighbors classifier model is implemented and the score of the k-neighbors classifier comes out to be approximately 70.4%. And the F1 score of the k-neighbors classifier comes out to be approximately 57% in this case. The predicted values are calculated and according to the decision tree classifier also the output is calculated. So this is the entire analysis of the Titanic dataset, which involves the formulation of the exploratory data analysis as well as the final build-up of the machine learning model, which can be used to predict whether a person will survive or not.